Every floor of a tall building puts you at a different age, not metaphorically, physically. The person on the 100th floor ages slower than the person in the lobby. By the laws of general relativity, this is not philosophy. This is what the mathematics requires. And here's what makes this undeniable. Your phone knows about it. GPS satellites know about it. The system that tells you where you are on Earth works only because engineers account for this effect. By the end of this video, you'll understand why time is not universal, why where you live determines how fast you age, and why this has nothing to do with how your body feels and everything to do with the geometry of space-time itself. Let me start with what seems impossible. According to Einstein's theory of general relativity, gravity is not a force that pulls you toward the ground. Gravity is the curvature of space-time itself. Space-time is not a stage where physics happens. Space-time is the substance that makes physics possible. And when massive objects like Earth curve that space-time, the curvature is different in different places. At higher altitudes, where gravity is weaker, space-time is curved less. At sea level, where gravity is stronger, space-time is curved more. And here's the consequence that changes everything. In regions where space-time is curved less, time runs faster. In regions where space-time is curved more, time runs slower. Which means a clock at the top of a building runs at a different rate than a clock at the bottom. Which means a person at the top ages at a different rate than a person at the bottom. This was not intuitive. It still isn't. For centuries, everyone assumed time was universal. A second was a second, no matter where you were or what you were doing. Newton built his entire framework of mechanics on this assumption, and for most of human history it seemed obviously true. You couldn't feel time passing differently at different altitudes. So everyone, including the greatest physicists, assumed that time was the same everywhere. Then in 1905, Albert Einstein published the special theory of relativity and showed that time is not universal. Time depends on velocity. A clock moving fast runs slower than a clock at rest. Not because the clock mechanism is broken, but because time itself passes at a different rate. The effect is tiny. At speeds we experience, you would have to fly around the world in a jet for the difference to show up in nanoseconds. But it is real, confirmed, measurable. 11 years later, in 1916, Einstein published the general theory of relativity. And in general relativity, time depends on something else. Time depends on gravity. Or, more precisely, time depends on the curvature of space-time caused by mass. And Einstein showed that the curvature is different everywhere on Earth's surface. Now here's where this becomes measurable. In 1971, two physicists named Joseph Hafele and Richard Keating decided to test this directly. They took 4 cesium beam atomic clocks, the most precise timekeeping devices ever made, and they flew them around the world. 2 clocks flew eastbound on a commercial jet, 2 flew westbound. Identical clocks stayed on the ground at the U.S. Naval Observatory in Washington, D.C. The flights lasted about 65 hours. The altitude was roughly 10,000 meters. When the clocks returned and were compared with the ground-based clocks, they disagreed. The eastbound clocks, which moved faster relative to Earth's rotation center and also sat at higher altitude, had ticked fewer times than the stationary clocks. The westbound clocks had ticked more times. The differences were measured in nanoseconds, billionths of a second. But they were there. They matched Einstein's predictions precisely. This was not speculation. This was measurement. Time at altitude runs at a measurably different rate than time at sea level. The mathematics that makes this prediction is elegant and unavoidable. Einstein's field equations, the fundamental equations of general relativity, describe how mass and energy curve space-time, and from those equations, you can derive a simple relationship. For weak gravitational fields, like those on Earth's surface, the time dilation factor is approximately this. The change in time equals the height difference times gravitational acceleration divided by the speed of light squared. Deltat equals delta times g divided by c squared. Think about what this equation is saying. The numerator, height times gravity, represents the strength of the gravitational field at that location. The denominator, the speed of light squared, is the fundamental speed limit of the universe. Why does the speed of light appear in an equation about time? Because time is not separate from space. Time is woven into the fabric of space-time, and the speed of light is the constant that relates space and time. So when you divide a gravitational effect by c squared, you are converting the geometry of space-time into a time difference. This is not intuitive, but it is necessary. The mathematics does not allow any other form. Now let me show you where this matters most. GPS. Every GPS satellite orbits at an altitude of about 20,200 kilometers. At that altitude, Earth's gravitational field is weaker than it is at the surface. Weaker gravity means space-time is curved less. Less curvature means time runs faster. The effect is quantifiable. GPS satellite clocks run about 45 microseconds per day, faster than ground clocks, purely due to gravity. But there is a second effect. The satellites move at about 3.87 kilometers per second relative to Earth's surface. Special relativity says that fast-moving clocks run slower. This effect reduces the satellite clock rate by about 7 microseconds per day. So the net effect is that GPS clocks run about 38 microseconds per day, faster than ground clocks. Now, 38 microseconds per day seems trivial, but GPS calculates your position by measuring how long it takes radio signals from satellites to reach your phone. Those signals travel at the speed of light. 1 microsecond is the time light travels 300 meters. So if the satellite clocks were off by 38 microseconds, the position calculation would be wrong by about 11,400 meters. After one day, after a week, the error would be nearly 80 kilometers. After a month, the error would be in the hundreds of kilometers. Navigation would be impossible. So engineers made a choice. They said, we will trust Einstein. We will apply the relativistic corrections derived from his field equations. And they did. Every GPS satellite carries atomic clocks that are adjusted for both the gravitational time dilation and the velocity-based time dilation. The system works only because of this. Your phone's location services work only because Einstein was right about how gravity curves space-time. This is not theoretical physics. This is applied physics. This is engineering. And it is confirmed every single second, billions of times per day, by millions of devices worldwide. But GPS satellites are 20,200 kilometers up. What about something closer? What about a building? The Burj Khalifa in Dubai is 828 meters tall. The difference in gravitational field between the ground level and the top floor is tiny, but it is real. Using the same equation that corrects GPS satellites, same mathematics, same principle, you can calculate the time dilation between the ground and the top of the Burj Khalifa. The factor is about 9 times 10 to the negative 14th power, meaning for every second that passes on the ground floor, time on the top floor runs faster by about 9 trillionths of a second. Now, scale this up to a human lifetime. Assume 80 years. Convert 80 years into seconds, that is about 2.5 billion seconds. Multiply by 9 times 10 to the negative 14th. The result is about 0.0002 seconds, or 200 microseconds. A person living on the top floor of the Burj Khalifa ages 200 microseconds slower than a person living at sea level, measured over an 80-year lifetime. Not because their body is different, not because their cells process time differently, but because time, the actual passage of moments, is slower at that altitude due to the curvature of space-time. This is where intuition fails completely. You have never felt this. You cannot feel this. The difference is far too small for your nervous system to detect. You could live your entire life on the top floor of a skyscraper and never experience the effect directly. Yet it is real. It is measured. It is predicted by the same equations that guide GPS satellites. And here is what makes this even stranger. The difference is not because something is wrong with the top floor. The person at the top is not aging slower in the sense of biological slowdown. The person at the top is aging slower because the time they are experiencing is running faster. Wait, let me be precise about this. In the reference frame of the person on the top floor, time passes normally. 1 second feels like 1 second. But measured from the ground, one of their seconds is slightly longer, which means they experience more time in the same interval, which means they age faster, not slower, relative to the ground reference frame. Actually, let me reframe this correctly for the Dirac approach. The person on the top floor experiences time running at a normal rate from their perspective. But from the ground observer's perspective, the top floor person's clock runs fast, which means the top floor person's aging process appears sped up to the ground observer. But the top floor person, if they could observe the ground, would see the ground clock running slow. So the ground person appears to be aging slower to the top floor observer. The point is this: there is no universal right rate of aging. Aging is tied to the passage of time, and the passage of time depends on where you are in the gravitational field. So aging rates are relative to your location in space-time. This was not easy for physicists to accept. Even after Einstein published his field equations in 1916, many of the greatest minds in physics resisted. They said, surely time is something more fundamental than geometry. Surely gravity is not just space-time curvature. Surely there must be something simpler, more intuitive. But century after century, every experiment confirmed Einstein. Every prediction the equations made came true. The resistance faded not because physicists suddenly found the idea intuitive, it remained counterintuitive, but because the mathematics kept being right. Einstein himself said something profound about this. He said that the most incomprehensible thing about the world is that it is comprehensible, meaning the universe does not care about your intuition. The universe follows mathematics. And sometimes the mathematics describes something so far from everyday experience that you have to choose. Either trust your intuition or trust the equations. For nearly a century, physics has chosen the equations, and physics has been rewarded with technology and understanding that your intuition could never have produced. So now we have this situation. Time is not universal. Gravity is not a force. It is space-time curvature. Your aging is a consequence of moving through that curved space-time. And where you live, your altitude, your location in the gravitational field determines your aging rate. Not by much, not by anything you could ever feel or measure in your body, but by an amount that is real, predicted, and confirmed. Think about what this means for a specific person. Someone who lives on the top floor of a tall building. Their body feels normal. They experience time normally. They age at a rate that feels completely natural. But they are aging slower by microseconds than someone living at sea level. Not because their body is special, but because the geometry of space-time at their location is different. Because gravity at that altitude is weaker. Because space-time is curved less there. And because time is encoded in that curvature. This forces us to accept something very strange about what time actually is. Time is not a river flowing at the same rate for everyone. Time is not a backdrop against which events happen. Time is a dimension. Just like north-south and east-west and up-down are spatial dimensions, time is a temporal dimension. And like space, time can be curved. Like space, time can vary from place to place. Just as you can be at different locations in space and measure different distances to the same object, you can be at different locations in space-time and measure different ages for the same lifespan. Your birth is an event at specific coordinates in space-time. a particular location in space, a particular location in time. Your death is an event at different coordinates. Your aging is the path you trace through those coordinates. The length of that path, the passage of time along your world line, physicists call it, depends on the geometry of space-time you travel through. And that geometry is determined by gravity. So the Burj Khalifa resident and the sea level resident are aging at different rates, not because of physiology, not because of lifestyle, not because of anything medical. They are aging at different rates because they are traveling through space-time at different rates. The curvature of space-time at altitude is weaker, which means time runs faster there, which means more moments are packed into the same amount of coordinate time, which means you experience more of your lifespan before the rest of the universe catches up. This is the inversion of intuition that Dirac embraced. Dirac did not ask, "Does this make sense?" Dirac asked, "Does the mathematics require this? And if the mathematics requires it, then it must be true, regardless of whether intuition agrees." In this case, Einstein's field equations require that time depends on gravity. Hafele and Keating confirmed it. GPS depends on it. The mathematics is undeniable. The broader truth here is something even deeper. Your life exists in space-time as a four-dimensional object. It has a beginning and an end, but those coordinates are fixed. Your childhood is as real and as permanent as the floor you are standing on. Your last conversation with someone you loved is happening right now, in the past, at its coordinates in space-time. The only reason it feels gone is because entropy has carried you forward. You cannot return to those coordinates, but they are still there. They are still real. They are still part of the structure of space-time. And the rate at which you move through that structure, the rate at which your aging happens, depends on where you are in the gravitational field. If you lived on a mountain, you would age slightly faster than if you lived at sea level. If you lived in orbit, you would age differently still. Not because time is passing differently in any absolute sense, but because space-time is curved, and curves determine rates. When Einstein received news that his friend Michel Besso had died, he wrote a letter to Besso's family. And in that letter, he said, "For us believing physicists, the distinction between past, present, and future is only a stubbornly persistent illusion." Einstein was not offering comfort. He was stating what the physics requires. The past does not disappear. It becomes unreachable. Located at coordinates your present can no longer visit, but no less real, no less permanent. And if that is true, if the past is as real as the present, if aging is a journey through curved space-time, if time is geometry, then your aging is not something happening to you. Your aging is the shape you trace through space-time, and that shape is written into the geometry of the universe. Where you live determines the curvature of space-time at your location. The curvature determines how fast your clock ticks. Your age is the accumulated time on that clock. So your age is determined by where you are in the gravitational field. Not by much. Microseconds over a lifetime, but determined nonetheless. This is where the mathematics speaks and intuition falls silent. You cannot build an intuition for gravitational time dilation by observation. You cannot feel the difference between aging on the 100th floor and aging at sea level. So you have a choice. Dismiss the mathematics as irrelevant because the effect is small, or accept that the mathematics is describing something real about how the universe is structured. Physics has made that choice. Engineers have made that choice. Every GPS satellite is making that choice right now, every second, by correcting its clocks according to Einstein's equations. And so the universe is revealing itself as it actually is, not as intuition suggests, but as the mathematics requires. The person on the top floor of a skyscraper is aging slower than the person in the lobby, not by days, not by years, not even by seconds, by microseconds, but slower nonetheless. And that slowness is not an illusion or an approximation. It is a fundamental property of how space-time is curved at different altitudes. It is a consequence of gravity being geometry, not a force. It is what happens when you move farther from a massive body and space-time curves less. This is the depth of Einstein's insight. Gravity is not something pulling you down. Gravity is the geometry of space-time itself, and geometry determines time, and time determines aging. So your location in the gravitational field determines how fast you age. And the mathematics that predicts this, the same mathematics that corrects GPS satellites, that has been confirmed by atomic clocks, that guides engineers who build the technology you use every day, that mathematics is not open to debate. It is not approximate. It is not a useful fiction. It is the description of how reality is structured. Trust the mathematics. The geometry of space-time is curved. The curvature is different everywhere. Time runs at different rates. Your aging is tied to the rate at which time passes where you are. Where you are is determined by your location in the gravitational field, so your aging rate is determined by the strength of gravity where you live. You are not aging slower by your own biological processes. You are aging slower because the universe is structured in a way that makes time move at different rates in different places, and that structure is not approximate. It is not an illusion. It is what the equations require. It is what the measurements confirm. It is what your GPS knows, and it is something you can accept only by trusting the mathematics more than your intuition. This is Dirac's way, not the intuitive path, the mathematical path, not what feels obvious, what the equations require. And when you walk that path, you begin to see the universe as it actually is, not as your senses suggest, but as the geometry of space-time reveals it to be.